Check one. Check one. Hello. Good evening, everyone. I'm Malit. I'm from WSO2. I hope everyone can hear me now. Maybe one of you want to just uh, pin me and let me know whether you could hear me. Okay, let me give you like a very brief introduction to myself before moving forward. So I have been with WSO2 for almost 5 years now, right? So during this time, I have worked in multiple different areas and have led multiple different teams such as research, product performance, and so on. So recently, my main focus has been working with observability and AI. So basically, there I lead two teams that develop features in these two areas. Right now, prior to joining WSO2, I was actually overseas for many years, mainly based in Australia and New Zealand. Basically working in again different roles, research engineer, software engineer, technical lead, software architect, and so on, right? So, okay, now let's start the session. So today, what I would like to do is basically talk about how we can use machine learning to basically solve problems in aPaas. Okay. Now, so basically now so aPaas actually stands for Application Platform as a Service, right? So some people call this PaaS, but so throughout this presentation, I would like to use the term aPaas, which is Application Platform as a Service. Okay, so what is the definition of aPaas? So I have, if you Google for this, I guess you get multiple different definitions. So the Wikipedia definition of aPaas is a category of cloud computing services that provides a platform allowing customers to develop, run, and manage applications uh, without complexity of building and maintaining infrastructure, right? So it seems like I am getting some error. Okay, let me pin. Can you hear? There seems to be a streaming error. Okay, so let me continue. We might have disruptions like this, but that's okay. We will continue, right? Okay, so then basically, uh, okay, so then basically now, so there is infrastructure as a service, right? And then also there is SaaS, which is software as a service. So actually the aPaas actually sits in the middle, right? So why actually aPaas? Why do you want to use platforms like aPaas? Actually, there are multiple reasons. Now, as I pointed out earlier, so the one main reason is it eliminates the complexity of building and maintaining our own infrastructure, right? So then also it is cost effective, right? Because there is no operational costs. You don't need to maintain your own infrastructure. So also, aPaas actually provide rapid application development. Basically, you can get things done faster. So the reason, the way we do that is basically by by providing uh, by providing. Is there anything happening? Or I can see on the chat. Okay, right, fine. by providing environments such as low code. So basically, build applications using graphical tools, right? So once you have such graphical tools, you can do application development faster. So the second, also another reason why we need, why we use platforms like this is the scalability. Okay, so if you can develop apps, but you will get into problems when you start deploying it yourself, right? Especially once when the load increases, right? Basically, then you have to scale, right? So now, so this scaling can be quite tricky, right? So therefore, once you deploy it in aPaas, then it's all handled for you, right? Now, then also the flexibility part of it. Now, developers can develop using their choice of programming language, which could be Java, any programming language. And also, as I mentioned earlier, there is also low code. So you could use code or low code, right? So basically, aPaas allows a set of developers with varied set of skills to develop applications. Okay. So basically now assume that you are working in or building a platform like this, an aPaas platform. So where does the machine learning come? Okay, so actually now there are many different areas where you could actually use machine learning, right? So, but these use cases are based around the application, right? So, which is the main thing which you would do, basically use aPaas to build an application, right? So let's now take a look at the core areas. Now, so basically, now there are a couple of main areas which are actually important for WSO2 also, like in general. Now let's take one and talk about it. Now let's take testing, right? So when you develop an app, you have to test it, right? So there you could use machine learning to generate test cases. So test cases in the sense, you can generate unit tests, but also you can also try to generate load testing scripts, like if you have JMeter or something, then you basically can generate such things, right? Such tests. Then also performance. Now performance is a very critical aspect, right? It's a very critical non-functional requirement. You can use machine learning to improve the performance, right? Also, there is a scalability side where you could use machine learning to, for example, come up with novel scaling algorithms. So what happens is, like these default algorithms, scaling algorithms in environments such as Kubernetes, sometimes they have issues. So, and you might have some additional requirements, for example, providing latency guarantees. You want to scale to ensure that the response time is maintained at below certain levels, right? Now, then also the deployment side, right? So there are several use cases. For example, like when you deploy an app, how do you actually compute or figure out the optimal resource allocation? Are we going to allocate 1 core or 2 core, and so on, right? Also, another big area is observability, right? So observability is actually, that means like basically monitoring the app and then gathering the information and getting more insight into its behavior. So there are, of course, there are two areas where we could use machine learning. One is to do anomaly detection, which I will go through later in detail, and also troubleshooting, right? Then there is another area which is developer experience. Remember what we do in aPaas is, you log into this thing and then you develop things, right? Develop applications. So then there are many things like, so which we can do to improve the developer experience, right? So what I will be doing today is basically pick four of these main areas. So I'll pick performance, deployment, observability, and developer experience, and then take a use case from each of these areas, and then talk about how we go about doing it. Okay. Okay, so I would actually like to start with performance, because now performance, of course, is something that we have been working on for a long time, right? So some areas are actually new to us, but the performance is not. So now, so the question we ask here is now, how do we use machine learning to improve the performance of an app deployed in an aPaas like platform, right? Now, as I mentioned earlier, performance is a critical non-functional requirement. Now, when it comes to measuring it, there are two metrics, right? I think most of you probably know this is throughput and the latency. So the throughput is the rate at which the app is processing requests, right? So this figure shows how the throughput changes with the load. So as you could see, when you increase the load, the throughput will increase, and then it actually comes to some, it stagnates, and then after a certain point it goes down. So that is when it actually gets overloaded, right? So the latency is kind of like a measure of waiting. So depending on the context, basically definition of the latency might change. But in this particular case context, we are talking about the response time. So but what happens is latency, actually this response time is not a single value, right? So it exists in a form of a distribution, right? Because you have many latencies. So when you talk about the response times of the latency, we calculate certain statistics of this distribution, such as the average or the 99 percentile, and then we basically use that measure to talk about it, right? Compare. Okay. So what do you mean by then optimizing the performance? So basically what that means is you want to either optimize the throughput, or you want to optimize the latency or the response time. So one way to go about this is to basically now is performance tuning, right? So tuning is actually not new, right? But using machine learning to tune is relatively new, right? So not many people actually do this, but now I think more and more people are trying to explore these sort of techniques to get the performance improved, right? So the basic idea is that there is some application, right? Then there are parameters. We call this, some people call these knobs. These will have the impact on the performance, which is the output, which is measured using throughput or latency, right? So the objective is to basically find the optimal parameters in order to get the best throughput, which means the highest throughput or the lowest latency. Okay, so what can we actually tune? Okay, so actually there are these parameters come from different layers, right? So we could actually tune, for example, application layer parameters, like I mean certain products have like connection pool sizes, thread pool sizes, and so on. Or you can try to do DB tuning, which we have tried to some extent, or even we could try to do JVM tuning if you are using Java to develop, right? Now so this is how one idea of how we can do it. So there's an app, right? Now, so remember the app, so we are trying to optimize the performance of this app. So then there's a tuner, right? So basically what happens is tuner is supposed to tune it and then get the performance improved. So the another use scenario might be, you might build an app using multiple apps. So in that case, basically the objective is to improve the performance of that big app which you make, which consists of different apps, right? So what happens is now, so the tuner will actually query the app and then get the current parameter values, right? So if it's, for example, thread pool size, what is your current thread pool size? And also the performance measure, this performance metric, you can basically design it such that you can get those metrics through API calls. Okay, so if it's latency, you can measure the latency within the app. Okay, so you query for that, and also other features. So remember, there are parameters which you're trying to tune, and also which we are trying to tune, which might be a thread pool size which you're trying to optimize. Then you want the value of the performance metric, which can be the throughput or the latency, and then also you have the features. So the features might be the CPU utilization, like the memory utilization, and so on, right? Now, so that is the basic idea behind tuning. So then these ones get fed into a model, uh, and then the model is supposed to return the best set of parameters, and then you basically send these back to the app. So the app will then reconfigure itself, right? Okay, so that is the high level idea of tuning. Now, so this tuning actually can be done online or offline, right? The online is in production, or you could tune it offline. Offline means like before you actually go and deploy it in production, you can tune it like in your test environment, right? So that is also possible. Now, talking about this one little bit more, we see that there are actually 4 levels of this. Now, this actually, just try to understand this. Now, so how about training, right? So training the model, of course, can be done offline. So then you have to use pre-collected data for that particular app, and then you can build a model, and then basically you can use that model to optimize for particular set of scenarios. Then you get the parameters. So then we deploy with those parameters, but then those parameters then won't change. They will just stay there. So the issue with that one is, like, if the workload changes or some traffic pattern changes, then of course you might get into issues, because now then because you have actually tuned for one particular case and you have deployed it, but now you are seeing a different behavior, then you might see a degradation, right? The second case is actually you can train offline, but remember this requires a lot of data, right? When you do training offline, because you need to capture all the data should represent range of behaviors, right? So if you just use a small set and train and then you deploy it online, then you might not see the behavior that you would expect. So you can train offline, right, using a data set, and then you can try to tune online. At least this is better than the previous approach. It can, to a certain extent, address the issues that we saw in the earlier case, right? Now, the third method is basically you also train the model online. Okay, so train the model online, and also you tune it online, right? So then actually now if you go with this one, then you don't need any data at all, right? So you can start with no data, and as the data comes, then you can train the model using that, and then you can use that model to basically derive the parameters, optimal parameters for that time period, right? So now one issue with that one is, like, because if you start with no data, then what happens is, the model will try to do some exploration, right? Now so then initially you might see some unexpected behavior. So what we actually do is, we train it little bit using some pre-collected data, and then train it little bit offline, right? And then we train it online and also tune online. So that eliminates those certain strange behaviors that you would see at the startup. Okay, so in terms of techniques, if you're going for offline techniques, you can use any traditional machine learning model, or you can go with like deep learning models, right? But what we have tried to actually do was basically try to do online training and then do the optimization also, tuning also online. So we have actually used Bayesian. So we have spent quite a bit of time understanding how Bayesian works, because Bayesian is actually not something that you can learn very fast, like not like other techniques. Now it actually did work. Now I will show you some results. Now here in this case, okay, so we are tuning a single app, right? So I am talking about the case where someone writes a app and then you deploy it, and then we are tuning to get the better performance. So in this case, we are tuning just the thread pool size. Now thread pool actually size has a significant impact on certain performance metrics, not all performance metrics, right? So here we are trying to tune the 99 latency percentile, right? So the lower the value, the better, right? So the default is in blue, right? And the auto-tuned one is in red. So as you could see that the latency has, the 99 percentile latency has improved. So when talking about latency or the response times, you always want that value to be low, right? So in fact here we are getting 46% improvement as a result of tuning. Okay. Now then what we tried to do was we basically increase the number of services. So now we are making a use case now, but you are creating multiple labs. Think of it as microservices, right? Which is trying to using multiple microservices, you are implementing a use case. Now basically you want to optimize the performance of this big app which consists of multiple microservices or multiple apps. Now what we noticed was in that case the performance improvement is even higher. Okay, so because now rather than tuning the thread pool of one app, you are tuning two, right, which results in better improvements, right? So that is one area that we have worked on, and then we got very interesting results. So then I think the next area that I would like to talk about is deployment, right? So now one thing to mention here is that so basically now there are various use cases, and basically when we want to implement these, you will have to go and talk to different layers in your platform. Okay, so it might be the Kubernetes, it might be the presentation layer, it might be the observability, and so on, right? So in this one, so this one actually I am going to do it very briefly. Now what happens here is basically what we try to do is trying to use machine learning to resource allocation, okay, for apps. Now how many cores to allocate, how much memory to allocate, and so on. Okay, so here, okay, let's narrow it down a bit. Okay, let's assume that we have two apps, right, app 1 and app 2. So you are trying to optimize the resource allocation here. Now let's assume that, so the client is accessing using this app which consists of app 1 and app 2. Okay, so the request first comes to app 1 and then it goes back to app 2 and then goes back through to client through app 1. Okay, so that is the path that the request would take. Now we are trying to basically figure out how the co-allocation for these two apps, right? Now, so basically let's assume that we have fixed budget, now fixed number of cores, right? Now, so this actually simplifies to the same kind pointed out earlier. Now, so these are some performance results. Now you could see, okay, so we have 4 cores to allocate for app 1 and app 2, right? So here what happens is, now we have varied the co-allocation for app 1 and app 2 and then measured the performance, right? So for example, the one which is highlighted in blue, you could see that we are getting a throughput of 5,000, right, by allocating app 1 2.5 cores and 1.5 cores, smaller value than that, for app 2, we are getting the best throughput and the best latency, right? Now, whereas if you go for the equal allocation, which is 2 and 2, right, the performance is not as good as the previous case. So, right, so basically now allocating equal amount of resources, you don't get the best performance, right? So this is what actually this is what these results show. Reliant on the number of IO calls. So basically now the app 1 actually it has to do 2 times more IO compared to app 2, right? Because app 2 will just receive the request from app 1 and then it send the request back, whereas app 1 it is receiving the request from app from the client, and then it sends it to app 2, and then it get the response back and then sends it back to client again. So basically the amount of IO so which results in more processing also. So there is this OS level processing because it's doing IO, we call this the kernel CPU, is higher in app 1. So therefore we need to allocate more resources for that in order to get the best performance, right? Okay, so now we can use the same techniques, so the Bayesian or the reinforcement learning, to solve this problem, right? So the way we do that is we basically initially set some values, like you can start with 1 and 1 or something, and 1 and 3, and then we feed it back to the we basically set it to those values and then run a test and then get the value of the performance metric, and then we feed it back to the model. So we continue to do like that while trying to optimize the metric. So basically then these core values will converge to some optimal values which you can then go and deploy, right? Okay, so that is a use case in deployment area. Now I would like to move on to observability. So as I mentioned earlier, I will be talking about use cases in performance and deployment, which we have just completed, and then the observability, and then later on we will go to basically user experience, right? So observability is a main part of aPaas, right? It is about monitoring and analyzing and getting insight into how a given app piece or service is performing. So observability actually has 4 pillars. We call these pillars. Right now, the first one is the matrix, right? So the metric is a numeric representation of data measured over an interval of time, right? So you might, for example, measure the average latency of your service every 1 minute, right? So the metric value is the average latency in that minute, right, or the standard deviation. When you talk about tracing, which is the second one, there you are talking about basically looking at a single request start to end, right? End-to-end request flow of a causally related set of distributed events, right? So the third one is the logs, which is self-explanatory. It is basically the timestamp record of discrete events that happen over a period of time, right? Now, so the use cases in observability which relates to machine learning, there are mainly two. One is detecting anomalies, and second one is troubleshooting. So how can we use machine learning to help the user to troubleshoot an issue in an app, right? Now I will only be focusing on anomaly detection right now. So basically, so what is anomaly detection? Anomaly detection is the identification of data points, items, observations, or events that do not conform to expected pattern of a given group. So that is the definition. Now anomaly detection pinpoints where the user needs to focus on. Okay, so it's a push model, right? Why why we have to automate this detecting anomalies. So of course you can't go through all the data to find anomalous behaviors in applications, right? So that is not possible, right? Also, you cannot continuously monitor the dashboards, and I mean there can be many dashboards, and when your app gets bigger, then it is practically impossible. Also, one thing which comes up here is that do we go and develop a single model for all apps, or do we develop multiple models for each app, right, for detecting anomalies? Now, it is usually not practical to develop a model per app. So therefore, I think if we could go with a generic model that works across all apps, then that would be the ideal solution, right? Now, before we move forward, now let's see what can cause an anomaly. Okay, so the anomalies actually can happen due to many reasons. Now, these are some of these reasons. CPU hog. CPU hog is basically high CPU usage in a container, or memory hog. Similar to CPU hog, the memory usage can go up. The other reason is the increased load. Like for example, there can be some event happening, and then as a result, you might get like many users, like many concurrent users accessing your app. Okay, so that could actually result in anomalies, right? And also slow backend APIs. Now, what that means is like when you develop an app, right? Usually, you have to talk to external APIs, like sometimes you call them backends. There might be long delays in those API calls, which would cause timeouts in your app. So this would cause anomalies in your app, right? So this is a very common scenario where we actually get anomalies. Okay. Also, there is network hogs, which is basically the network gets saturated. So as a result, the app's behavior become anomalous, right? Now, let's see how we could use uh, metrics to do anomaly detection. So metrics I mean the application metrics, like for example response time, throughput, and also there can be system metrics, which is CPU utilization, memory usage, and so on. Using these metrics or using them as features, how can we do the anomaly detection, right? There are two ways. Now, the first one actually we have tried out. You can just do the univariate thing. You take, one series at a time. For example, you can take the latency and then try to detect the anomalous behaviors such as spikes and dips, right? So in this diagram I have highlighted it. So basically you could see some, I'm not sure whether you could see, you can see a dip here, right? Or alternatively you can have a spike, or you can have a level shift, right? So that is a change in the value of the metric, right, for a period of time. Those sort of things can be detected if you use, so univariate anomaly detection can do those sort of things, but that is not the best way to do it. The best ideal approach is actually to go with the multivariate detection of anomalies. Now here I have a plot. Actually, what this is something that we got from one of our experiments. Now here this is a network hog. Basically, there's a network saturation which occurs right now. Then as a result, you could see this blue line, which is the response time, has increased, right? So in the middle here, basically where the anomaly is happening, right? Uh, so okay, in the middle is where the anomaly is happening right now. So when the latency goes up, so the latency actually goes up as a result of the network saturation, and also the CPU utilization has gone down, right? So the reason is, now remember, the network saturates means like your CPU gets underutilized, right? So there is nothing much to process. So you could clearly see that the CPU utilization is now going down, right? So these sort of anomalies can be detected using multivariate anomaly detection. Now, one thing which is worth pointing out is that now if you are going for a generic model, we have to actually go and find out app independent features, right? So we can't use, for example, absolute value of the throughput, right? So one app might have like 1000 throughput and other one might be just 1. So that is one point. Now also the other point is we have to make sure that we normalize and standardize the data over all apps when we build this model. So people have actually used even statistical methods, right, to do this. Like for example, fitting the data into a Gaussian distribution and then basically using that to do the anomaly detection, right? Because you can basically feed it back the new point and then you can make a decision whether it's in those tail regions. Then you basically classify it as an anomaly. But as far as the ML based model goes, if you do have label data, you could even use methods like light GBM or XGBoost. We have actually tried to use light GBM, so that was actually not bad. We got reasonably good results. But so most of the time there is no label data, so you have to go with unsupervised techniques. So isolation forest is quite common, and we have actually even did a model using k-means clustering and deployed it in production. But now what we are trying to do is actually trying to get the accuracy improved. So now actually we are trying to use semi-supervised techniques. One particular one that we are trying to do is this DevNet approach, right? Okay, so coming to the last item, which is the developer experience. Now, so again, going back to how this relates to aPaas. User is using a platform where he is developing applications, and then there are many ways which the developer can develop these applications, right? So one method is actually to use low code. So low code is actually now becoming popular these days. Now, so under low code, there are use cases where we can actually use ML to basically improve that user experience, right? So data mapping is one. I will actually show you what it is and something we have done. And also auto-filling of forms, like in low-code environments, as you probably know, there are forms, right? So when the user opens it, you want to actually try to auto-fill these forms using the data or the information which you already have, right? And also predicting the next element. So basically you are building an app using graphical blocks. You want to basically predict the next element. Those sort of use cases are there. Then the code also, there is data mapping. That also I will show you how we did that. But mainly for code, the most important thing is the AI based code prediction, right? So there of course there are existing plugins such as Tab9, which is based on GPT-2, and I think now there is this GPT-3 also, right? So there are range of use cases in the developer experience area where we could use machine learning to improve the user experience, right? Okay, so let's take a look at the data mapping a little bit in little bit more detail, right? So what is data mapping? So when you develop an application, right, what happens often is that you have to integrate different things, right? So there is one you get one message which will have a different format, and then you want to write it out to a different endpoint which will have a different format, right? I hope that you understand the problem here, right? Now, so usually these schemas for these messages are available, okay, at least in this scenario. So what we try to do is we basically upload the schemas of these two different messages, and then we basically try to map the attributes of these schemas. Okay, so let me now show you how using one of so this is something that we have implemented in this product called WSO2 Integration Studio. Okay, so here, okay, now we are loading the first schema, which is on the left side, right? And then you load the second schema. So this is low code, right? So you are using the graphical components to build your use case, right? Then you do the mapping, and then it does the mapping, right? So so there is a backend service, AI service, which it connects to, which will, so this, when you play the map, when you press the map button, these two schemas get sent to that service, and then that service will does the mapping and return the mapped results, right? And then that gets applied to the UI, right? Okay. So okay, so this is a screenshot of that. So we have a schema here, and then this is the output schema. Right now we want to map these things. Now if you take the first one, also notice that the hierarchy is also different, right? So these elements can appear in different levels, right? So here we have id string, which actually got mapped to owner id on the other side, right? Now, so usually, like sometimes you get schemas which have like hundreds of elements. So when that happens, I think this becomes quite useful. Right now, in this case, of course, you could still to a certain extent go and do it manually, but when you have like big very very lengthy schemas, then basically the AI based mapping becomes very handy. Okay, so in terms of how we did it, let me briefly go through this now. So basically what the way this is implemented is now, so there is of course some training schemas. Right now you have to have you have to first train the model. No, so we extract features from the attributes. So attributes in the sense, now here an attribute is name and string, and then also the position of it. We basically create some we create a feature vector. So this feature vector is basically we use word embedding. So and then we add more things to the feature vector, such as we can take the data type and so on. So we create some feature vectors, and then we basically do clustering. Okay, we cluster them, and then we get it into different classes. Okay, then we train a classifier, which is an XGBoost model we have used here. Actually, this is the first implementation which we did. Now we have slightly improved one. So this classifier can then go and basically classify these feature vectors into different classes, right? So when a new schema comes, you feed them, and then this classifier will classify into different classes. Then those that go into same class, we try to map them. Okay, so they are the basically similar ones, right? Of course, there are some pre-processing steps, right? But high level, that is what we actually try to do. Okay, so this diagram shows how that is done. So we have schemas, and then we basically cluster them, and then we try to use the classifier to basically do the mapping. Actually, one thing that we wanted to avoid was basically we wanted to avoid, like for example, false positives, right? Which can be a problem, because if it maps the wrong thing to wrong thing, that might be an issue. So before we make that decision at the pre-processing level, we check few other things also, right? Okay, so I think this one I have already explained, like how we create features using the attribute name, the data type, and the hierarchy. Technologies we have used, of course, is here we have used XGBoost and then the word embedding, the word2vec. Right now, okay. So now then, so this is data mapping in low code, right? So you have the graphical thing and then you map it. So this thing will get connected to a backend service which does the mapping and it will return the result. Now this can also be done in code also, which is, this is a very interesting thing, right? So this program is actually written in Ballerina. So the Ballerina is a programming language which WSO2 has created. Now here we are trying to map. So in Ballerina there is this concept of record types, right? Now so basically types, right? So first one is the grades, right? The second one is the student. Now so what happens here is the user is creating a student, right, called Kamal, student record, which is Kamal, and then basically then he creates Kamal grades. So so which is an instance, or which is instance of grades, right? You then he tries to map, then he does this thing. So he makes grades Kamal grades equals Kamal. So Kamal is of type uh, student, right? Now these things are not structurally equivalent, right? So they are not the same. So basically you can't simply do these sort of things, right? Then what happens is, so actually this is in VS Code. I forgot to mention that. Then what happens is basically then this what is this called, this code action comes. So then it says, okay, generate mapping function. So now remember we have actually used the same backend in here and in even in the low code thing. Then if the user accepts it, then it generates a mapping function. So into the mapping function you actually pass Kamal. So it takes a student as an argument, right? Uh, which is of, so Kamal is, it returns grades, right? So here it actually does the mapping, right? It maps the parameters of students, you call these fields, to grades, and then it creates a new grades record, and then it returns it. Actually, so this one we have integrated to VS Code for Ballerina, right? Okay, I think we have almost come to the end of this session right now. So basically, what I wanted to point out in today's session is like, so I actually aPaas is a very big area, right? So when you start developing an aPaas like platforms, there are various areas that you can start working on, right? So for example, testing, scalability, performance, developer experience, observability, deployment. So I have actually looked at 4 areas in detail: performance and how we can use performance, how we can use ML to optimize the performance, and then we look at deployment related use case, and then observability, which is also another area, how we can use ML to detect anomalies in apps. Right now, also developer experience, which is again a big area. Right now, so basically now, of course, there is no resources to work on all of these use cases, right? So basically now, so the prioritizing it and then understanding the business value of the use case is critical, right? So this is something actually we do, because you don't want to actually, the use case might be interesting, but there is no business value, right? Or the business impact might be not that significant compared to doing some other use case, right? So basically we identify the most critical use cases, right now, and then we have AI engineers and also research engineers. We allocate them and then we implement them, right? Then basically now there are also other use cases which are not very important, but could be very interesting, right? Now those ones actually we run them as final year projects or even master's projects. So then we can get a feel of how the initial results could be. Some of those projects have been quite successful, but it takes time actually. Okay, so I think that is the end of my session today. Thank you very much, Tarindu, for inviting me for this, and thanks a lot. Thank you.